Okay, so let's move on here. Quick review. Yesterday we talked about how we add, subtract, and multiply polynomials. Super easy stuff. No big deal. That's, it's for you guys. It's short assignment to do, but it's no big deal. Polynomial product patterns, no big deal. Now we want to move on and look at how we divide polynomials. It's not like it's crazy hard stuff, but there's a method to it that you got to follow. You got to be very precise and careful about this. So I want to go through a couple examples and show you how it's done. Start with maybe an application here. What if we know that we've got some rectangular prism and we know the volume is 1200. We know that one dimension is 12, one dimension is 9, and one of them is unknown. Call it h. How do we solve for h? What do you think? Divide by the, so what you're saying is we could set up the equation. We know that the product of the three dimensions, right? So 12 times 9, which is 108, right? So we get 108 times h equals the volume, right? So all we have to do is just divide each side by 108, and we got the answer. Okay, well, let's do that division. It's been a while since you've probably done any division by hand, right? So h is equal to that quotient. If I wrote that out, let's use long division. If I were to write that out, what goes inside, I don't even remember what that's called, a little division. What goes in there? The 1200 goes inside, whatever's in the numerator. 108 goes outside, right? Now, how do we do this? It's been a while. Okay, so we can go over as many digits as we need to until the number outside, the denominator, divides in at least one time, right? Until it goes in, doesn't have to go in evenly. But 108 goes into 120 once, then what? Okay, I gotta multiply, right? So once I get a digit up here, I'm going to multiply that digit by what's out front, and I get 108, then I subtract, right? So I'm going to subtract that whole thing, and I end up getting 12, and then I bring down, did that right, didn't I? Yeah, bring down the 0, okay, and I do it again. 108 goes into 120, one time. I'm going to multiply again, and I get 108, subtract, and I get 12. Okay, right, and what do we do then? If we wanted to go with decimals, we would just keep going, right? But we don't want it. We want to get an exact answer. We want a fractional answer. So 108 no longer goes into this. So what did we call this? Now, no, what did we call it? I heard it. Yeah, the remainder. Yeah. So that's the remainder, right? Okay, so what does that mean, though? You tell me. A lot of times, you guys did something back in grade school, which I think is crazy. I don't think we should ever teach it this way. You guys would have written that answer as 11R12, right? Yeah. What does that mean? I mean, what does that mean? What good does that do you? Do you know what does that mean?
It means that a 5-year-old can't solve it.
Okay, it means 11, right? With 12 left over. But what good is that? We want a number. We want an exact number. What do we do with that 12? What is it? 12 over 108. Okay. Okay. Listen, please. We got a lot to get through. I need you up here, please. So yeah, that's what remains over the denominator. So what this means is that 12. It's 11, and we'd write it this way as a mixed number. It's 11 and 12/108, because that was our denominator. Okay, but even that, if we write it as a mixed numbers, that's middle school stuff, if that, for you guys. Probably grade school stuff, right? We left mixed numbers behind a long time ago. Mixed numbers are kind of dumb, too, because that doesn't even look like what it represents. What does that really mean? Does it mean 11 times 12 over 108? What's it really mean? 11 and, like if I say 11 and a half, does that mean 11 times a half? It means 11 plus a half, right? So this really means 11 plus 12 over 108. It's 11 plus the additional fraction, 12 over 108, which we could probably reduce, but we're not going to mess with it, right? Okay, so we can do the same kind of thing with polynomials. Okay, so let's just try to replicate those steps we just did with polynomials. There's going to be a few slight differences, but we're essentially going to follow the same mindset, same track of thinking on this. So if we write this out using a division bracket, I think it's called a dividend or something fancy like that, but I can't remember. What goes where? What's our pattern? It's the 3x cubed, so the numerator goes inside the division bracket, right? Okay, but here's the thing you got to be very careful about. Listen, please. So we started talking about this yesterday. Can you sort of see, based on the process we just did, that we're going to need to preserve a column for each power of x, because we're going to be doing lots of vertical subtraction, right? When we subtract polynomials, we have to be able to line up all of the terms, right? So when I write this in there, it's going to look like a 3x cubed minus 8x squared. I got to have an x term there, right? So we have to include, even though it's not there, we have to include a plus 0x plus 11, okay? Now we don't have to do that outside. That's not important because the subtraction is all happening vertically underneath the numerator, right? So we don't really have to do that stuff outside. That's not a big deal. Outside we're going to have our x squared minus 1, okay? Now think what we did next. We wanted to figure out how far do we have to go over for the 108 to divide in more than once, right? But less than 10 times, okay? So here, what's that mean? Well, x squared will divide evenly into, we're just going to look at the leading term, x squared will divide evenly into 3x cubed, won't it? How many times?
3x.
3x. Yeah. Now, how come? So let's think about that. Why did we get 3x? That's the right answer. One way to think about that is 3x cubed divided by x squared equals, well, look what happens. X cubed over x squared just becomes an x. So that's always going to work to think of it that way. A lot of times what you can just do, though, is ask yourself, x squared times what is 3x cubed? Well, 3x, right? So what do we do next, do you think? When we got a digit up here with numerical long division, we multiplied, right? So that's what we're going to do. We're going to multiply that. We're going to distribute it through, multiply it by the polynomial that's out front, the denominator. So 3x times x squared gives us our 3x cubed. That has to be the same. And then 3x times negative 1 is minus 3x. So it's going to go in the x column. And we're going to subtract the whole thing. So what you're going to do on your paper is you're going to put the whole thing in parentheses and put a negative out front. Don't just put a negative out in front of this term because that's not correct. You're not just subtracting that term, you're subtracting the whole thing, right? And when you're checking your work, you've got to be able to see that step, right? So then we just subtract vertically. These are going to cancel, right? What's negative 8x squared minus 0?
Why is there a 0 like under the negative 8x?
Because when I distribute the 3x through, I didn't get an x squared term, right? I only got an x cubed term and an x term. So when I subtract 0, that's the same thing, just bringing that term straight down, isn't it? So I get a negative 8x squared. 0 minus negative 3x is what?
Yes.
3x. So I get a plus 3x, and then I bring the 11 down, and I start over. Okay? So how many times does x squared divide into negative 8x squared? Negative 8. So we get minus 8, and we'll distribute that through. Negative 8 times x squared is negative 8x squared. Negative 8 times negative 1 is positive 8. And I'm going to subtract the whole thing. The negative 8x squareds cancel. I'll bring the 3x straight down because I'm subtracting 0 from it. And 11 minus 8 is 3. Okay. does x squared divide evenly into 3x? No, so we're done. So what is this? That's our remainder, right? So that's the remainder. So then, what is this whole thing equal to? Let's interpret this answer. So we know that that this whole thing is equal to I've got this part up here, right? It's equal to 3x minus 8, that's the polynomial part, plus, okay, so if this one, 3x plus 3 divided by my quotient, or my denominator of x squared minus 1, right? That's my answer. Okay? Now, looking ahead, we're going to talk about this in the near future. What would happen if x squared minus 1 happened to be a factor of the numerator? If it divided in evenly, how would my answer look different? There'd be no remainder, right? Everybody see that? Okay. All right, so let's try another one. When are we out of here? We have time for one more, hopefully? Oh, I think we do. We can. Oh, we got time. We can do this one. So talk me through this. What goes where?
For a numerator to the quarticness under it. Is it quartic?
That's a quartic and that's a cubic. Yeah. So what goes where?
Quartic inside.
Okay, so you tell me what to write. 4x to the fourth.
Plus x cubed plus 6x squared.
Got to have a column for every power of x, all the way through the constant, right? What goes out front?
Oh, you don't have a paper. Not gonna make it.
Made it. Okay, so how many times then does 4x cubed divide into, because we're just looking at the leading terms only, right? How many times does the leading term outside divide into the leading term inside? X. Yeah. Everybody see that? And once again, the reason is just 4x to the fourth over 4x cubed equals x. I'll distribute the x through, and what do I get? 4x to the fourth plus x cubed plus okay, now what do I write? Parentheses, negative out front, and I subtract. And look what happens. Those cancel and those cancel. That's good. 6x squared minus 3x squared is 0 minus 5x. And that's it, right? I could write the 0, but I can see already I don't have to. How come?
Not applicable.
But why? I would maybe have to write the 0 there if I were going to be able to continue the process, but I'm done, right? Because 4x cubed, I have an x cubed outside that I'm trying to divide into an x squared. I can't go any further. Now, if this were an x cubed, yeah, then I could, right? But it's not. So this becomes my remainder, and the answer is
X plus.
so what's my answer? So I get x plus, good, this stuff, divided by
Yeah, that whole thing, right. Make sense? Okay? That's pretty good. Well, we got 2 lots. Okay, so I've got 2 new assignments. One of them, I think, I don't think, but I'll put them up right now. Get a little practice on that.